Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on November 5, 2025, about 3 days ago. It introduces a simple black box detector that perturbs images in semantically meaningful ways and reliably flags contamination, with clean models improving on the perturbed inputs, while contaminated ones suffer drops as large as about 46%. The paper is titled Contamination Detection for VLMs Using Multi-Modal Semantic Perturbation. And as we will see later, the implications for model evaluation and trust are quite significant. Figure 1 illustrates a simple idea. A tiny, meaning changing edit, exposes whether a model memorized the test item. Semantic perturbation means altering the image so the correct answer flips, while the scene layout stays the same. Here, a new speed limit sign turns option B into option C. Clean models handle the change because they rely on reasoning, while contaminated models miss it, which signals memorization. So Table 1 compares contamination detectors against 3 requirements and shows that most methods miss the mark. Reliability means the signal holds across training styles, practicality means black box use without knowing leaked data, and consistency means the signal grows with more contamination. The rows with prior text-focused tricks show crosses for 1 or more requirements. Multi-modal semantic perturbation is the only row with check marks across all 3, indicating a robust detector. So Table 1 highlighted why a practical detector is needed, and Figure 2 shows how the detector actually generates perturbed samples. The pipeline first drafts a dense caption with a large language model, then uses ControlNet, which steers image synthesis with edge maps to keep layout while changing meaning. On the left, the original question anchors the scene. On the right, the perturbed version flips the correct answer, so any drop reflects memorization rather than reasoning. Figure Table 11 means the detector succeeds when contaminated models drop on perturbed questions, while clean ones stay steady or improve. The previous figure outlined the pipeline. This table presents outcomes across models and training styles, which matters because a reliable signal should not depend on internals. The top block shows consistent negative deltas for contaminated LLaVA with 1 to 3 epochs. The bottom block shows the same pattern for Qwen2 with LoRa and LLM only fine-tuning. Alright, 2 takeaways stand out. Multimodal semantic perturbation acts as a simple black box check for memorization, and the detection signal stays reliable across training styles and scales. The broader implication is clearer benchmark trust, since clean models stay stable or improve while contaminated ones drop, enabling routine, automated leakage audits. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.